Hey there, future PLC pros. Welcome to PLC HP, your ultimate hub for industrial automation mastery. I'm Mohammad Hatana, and this is brand new series. We are cracking open the world of PLC Siemens programming from basic to advanced automation. In this course, you will program Siemens S300 and S400 PLCs like seasoned engineer, master Siemens Simatic Manager, and build real-world projects step by step. Today's video, uh, what is PLCs? Stay tuned. Next up, Simatic Manager deep dive, followed by hands-on programming seasons, where we build together. Smash the subscribe button and ring the bell so you never miss a lesson. Drop a comment below. What automation topics do you want us to tackle? Let's engineering greatness. So, for the start of our lesson, we want to know what is PLCs. Today's course name is PLC Programming and it's specified for Siemens. What is a PLC? PLC and its applications. Programmable Logic Controller, or a PLC, is a ruggedized computer used for industrial automation. This controller can automate a specific process, machine function, or even an entire production line. How does a PLC work? PLC receives information from connected sensors or input device, process the data, and trigger outputs based on pre-programmed parameters. Depending on the inputs and the outputs, a PLC can monitor and record runtime data such as machine productivity or operating temperature, or automatically start and stop process, generate alarms if machine malfunctions. Programmable logic controllers are a flexible and a robust control solution, adaptable to almost any application. PLC difference. There are a few key features that set PLCs apart from industrial PCs, microcontrollers, and other industrial control solutions. I/O. This is short for input and output. The PLC's CPU stores and process program data, but inputs and outputs modules connect the PLC to the rest of the machine. Communication. In addition to input and output devices, a PLC might also need to connect with other kinds of systems. The communication usually use the Ethernet cable. HMI. In order to interact with the PLC in real time, user needs an HMI, or human machine interface. Now we will go by PLC sections. PLC parts includes power supply, central processing unit or CPU, memory, isolation bus, network card, input and output cards, programming interface. Power supply. The power supply converts power that will be used by CPU, memory, and the rest of the components. It normally is fused. It may have been a specified line voltage and varies by country. In United States, it's typically 120 volt AC and 16 Hz. Many companies have gone toward supplying the PLCs with 24 volts due to safety. Those our source power coming in could be 220 volt AC at 15 Hz and then converted to 24 volts AC. CPU, or the main processor. A PLC has a controller that is a CPU. The CPU will be able to take a program and convert the program into machine language. There will also be an interface such as an external PC for programming, so that an executable program may be downloaded to the controller. The machine language consists of sequence of I's inputs and O's outputs, or binary codes, telling the computer how to manipulate the inputs and what to do with outputs. A program is downloaded into the CPU and signals based on decision are sent out to the field. The program's purpose is to monitor the inputs and make decisions based on the application the PLC is being used. Memory. Memory may be part of the CPU or located on a separate card. The memory cards usually use the old RAM cards, or even the newer one use the memory flash. Wherever the memory is located, it stored data. Program is stored in memory as a runtime executable file. Each input and output will have a register or a location where the CPU keeps its values. Output registers are used to correlate to physical output location that will receive a signal once program and decides what to do with the input feedback. For instance, a table that corresponds the registers to the inputs and outputs could be used to step up and program. Even some PLCs applications will have these kind of register tables for memory allocation inside programming environment. Isolation bus. The power supply provides source power to drive the PLC and the inputs and output cards, or any kind of power on the PLC rack. Power and communication can be bused on the PLC backplane. Think about it as where the cards are seated on the bus. The cards on the PLC rack share power. They get the power of the bus. Network card or interface. The PLC has to be able to be networked or programmed, so there needs to be some physical communication port. This communication port may be an Ethernet IP port or a USB port built into the CPU, or a separate card type that connects to the bus. There are other protocol types as well, like Profibus, serial communications, and sometimes wireless radio interface. Another type of interface is I/O link. Programming interface. PLCs have programming interface where a connection may be made via Ethernet or a USB port. This port is used to connect the software design environment to the PLC. Inputs and outputs. The PLC chassis has slots that are allocated in the rack for the input and output. Field terminal blocks are wired to the input or output card. These allow versatility due to being discrete, analog, high-speed counter, or thermocouple input. There are many types of cards and card configurations. Power, space on the rack, and application needs will determine what kind of cards are required for a PLC to execute and meet the application requirements successfully. Thank you for watching. Smash the subscribe button and ring the bell and comment what you want for the next videos.